So, we'll now discuss the history of artificial intelligence. It's a rich tapestry woven from centuries of human curiosity, technological advancements, theoretical breakthroughs, and societal impacts. Early developments pre 1950s. So, this is the pivotal year 1950s. Ancient myths and automata, mythological concepts like in Greek mythology, mechanical servants, then Jewish folklore, the golem, an artificial humanoid, then mechanical automata, devices mimicking humans and animals, the mechanical Turk, a chess playing automation hoax, simulated real ducks movements and digestion, then foundational logic and mathematics, logical calculations, characteristic universal universal language for deductive reasoning, 1700s, then Boolean algebra, enabling logical operations, then predicate logic, then formalization of mathematics to derive all mathematical truths from logical axioms, then early computational theories in 1936, Turing machine conceptual model defining computation and algorithms, then lambda calculus framework for defining computable functions. Then comes the very famous Church-Turing thesis, which is a proposition that all effectively calculable functions are computable by a Turing machine. Then cybernetics and control theory, mainly 1948. So the study of control and communication in animals and machines, introduced concepts of feedback loops. Control and communication in animals and machines, introduced concepts of feedback loops. Early neuroscience and neural models. So neuron simplified computational model of the neuron. Simplified computational model of the neuron. Hebbian learning theory on how neural pathways are strengthened through repeated stimulation. Then the birth of AI. 1950 is the birth year of AI. Here, Alan Turing published the book Computing Machinery and Intelligence. The paper he proposed the Turing test as a measure of machine intelligence. It introduced concepts of machine learning and intelligence simulation. The Dartmouth Conference, Formation of AI as a Field, organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. They coined the term artificial intelligence and they set research agenda for the field. Then logic theorists developed by Alan Neville and Herbert Simon, first program to mimic human problem solving skills. Then general problem solving attempted to solve problems through heuristics like humans. The concept of heuristics came. Then Arthur Samuel's checkers program, early example of a self-learning program improving its gameplay over time. Early example of a self-learning program improving its gameplay over time. Then AI programming languages came Lisp, which became the dominant AI programming language for decades. Then came the concept of perceptron and neural networks. So perceptron is an early type of artificial neural network capable of pattern recognition. So it was believed that perceptrons could eventually mimic human learning. Now, this MIT Artificial Intelligence Lab, it was founded by Marvin Minsky and John McCarthy in 1959, and also in Stanford, then focused on robotics, natural language processing, and knowledge representation. So then came the era of robotics and physical AI, where the robot Shaky, the robot was developed by SRI International, the first robot capable of reasoning about its action. It was the first robot capable of reasoning about its action. Then natural language processing. So short super natural language processing. ELIZA, programmed by Joseph Verbaisen, simulating a Rogerian psychotherapist. It showed superficial understanding could simulate meaning and conversation. showed superficial understanding could simulate meaningful conversation. So, interesting observation. Limitations and critics, machine translation issues. Early optimism led to projects like the Georgetown IBM experiment being overhyped. The ALPAC report 1966 highlighted failures leading to funding cuts. Then Minsky and Papert demonstrated limitations of single layer perceptrons. Knowledge representation and reasoning, semantic networks developed for representing knowledge in interconnected nodes, frames and scripts for stereotype situations, and for understanding event sequences. First AI winter, mid 1970s, after 20 years, the winter came, reduction in AI funding and enthusiasm over promising outcomes. Fair AI systems fell short of expectations in real world applications. Critical reports, the Light Hill report criticized the failure to achieve AI goals, called for funding to be directed elsewhere. Expert systems and commercial AI revival, rise of expert systems, Dendrol developed at Stanford for chemical analysis. Rise of expert systems, Dendrol developed at Stanford for chemical analysis. One of the first successful expert systems. First successful expert systems. Expert system for medical diagnosis of bacterial infections. System for medical diagnosis of bacterial infections. Demonstrated the potential of rule-based systems. Commercialization of AI, corporate investment, companies started investing in AI for competitive advantage. Specialized AI hardware, development of Lisp machines optimized for AI applications, AI software companies, emergence of firms specializing in AI solutions. International AI projects, Japan's fifth generation computer systems project, an ambitious initiative to advance computer technology aimed to develop supercomputers with AI capabilities. Second AI winter, late 1980s, early 1990s, market saturation and disillusionment, failure expert systems. So there was a revival in the 1980s. In 70s to 80s, it was the winter. Then again, late 1980s to early 1990s, again the winter came. Market saturation and disillusionment, failure of expert systems, high development cost and maintenance costs, collapse of AI companies. Many AI startups failed, leading to investor losses. End of the fifth generation project did not meet its objectives, contributing to waning interest. Shift in AI research focus from symbolic AI to machine learning. Researchers began, this is important, researchers began exploring data driven approaches. Rebirth of neural networks, interest renewed due to algorithms and computational power. Renewed growth and machine learning era 1990s to 2000. Algorithmic advances, backpropagation algorithm 1986. Training of multi-layer neural networks. Probabilistic and statistical methods. Introduction to Bayesian methods and graphical models. Then Judeo Pearl's work on causality and reasoning. Notable achievements: IBM's Deep Blue defeated world chess champion Gary Kasparov, demonstrated brute force computation combined with strategic evaluation. Advancements in robotics, robotic pets, and industrial robots became more prevalent. AI applications in industry, data mining, and analytics use aware algorithms to extract patterns from large data sets. AI in finance and marketing, applications in fraud detection and customer segmentation. Modern AI and deep learning. Modern AI and deep learning revolution 2010 to present. This will cover in a different lecture in the next lecture. So that is all for now in this for this particular lecture. Thank you.